Good morning, everybody.
Good morning, sir.
Morning, sir.
Okay, so we'll start our lecture. In the last lecture, we have seen about the different types of rotors, and we were discussing about the vertical rotors, the fixed angle rotors. Okay, and I had shown you with this diagram the various placements of the various types of placements of the centrifuge tubes. Okay, so we have seen that in the vertical type of a rotor, where the tubes are kept vertically, in fact, parallel to the normal. Okay, so here the distance that the sample components will travel from one side of the tube to the other side, that is the maximum distance which is traveled by the particles. That distance is very small compared to the fixed angle rotors we have seen in this case or this case. Okay, where the particles have to travel a little longer. Okay, the maximum distance that the particles travel is longer than the vertical tube rotors. Okay, and then we have seen the advantage of the vertical tubes or tube rotor is that because the particles have to travel a smaller distance. Just a minute, I think. So we have seen that since the particles had to travel a minimum distance in the vertical tube rotors, okay, those particles which would take a rather longer time for a centrifugation, those particles will settle down to the other side a little faster. Okay, and therefore this is often regarded as a more rapid method for the centrifugation of small particles. Okay, whereas the drawback here is that because the distance is smaller, the resolution is not very good. So particles which are similar in the size or density, they cannot be easily separated from each other. Very often these particles would sediment together at the other side. In the case of the fixed angle rotors, however, because the distance the particles travel will be greater, okay, the resolution is better in this case, but then the problem is that that would take a little longer time for the sedimentation. Okay, then I think I asked you one question before the end of the meeting. I asked you a question, and the question was that if I want a very, very good separation between the particles, or if I want the particles to travel the maximum distance, okay, then what should be the placement of the centrifuge tubes? I think Shamim or Inamul, they wanted to answer that question, and then the meeting ended. So can you answer it now?
Sir, I said 45-degree inclination.
Okay, 45. Yeah. So that is why I think I tried to draw this particular tube at approximately 45-degree. And then, is there any other answer for that? Anybody else?
Clear separation.
Instead of 45-degree, if I take 55-degree, then what would happen?
45.
Is it not better?
Sir, maybe there will be chances that the liquid sample will be more spread on the wall, one wall or something like that.
So what happens? Is it a problem? if I make it say more than that, say 70 degree or 80 degree, then what will happen?
Sir, then the pellet, I think, will be more spread on the wall, sir.
So
And
what
it will
happens?
be hence
In fact,
sir,
it
will
would
be
go
difficult.
towards more towards the bottom, in fact. Okay, see, if it was a vertical tube, then the particles would go to the wall of the tube, isn't it? And then as we increase the angle, okay, from 0 degree, if I increase the angle, then in fact the particles are going more towards the bottom of the tube. Do you understand what I'm saying?
Yes, sir.
Ah. So the more the inclination, the more
Sir,
the chances that
but
the
I think,
yes.
sir, won't be handling more difficult if kept at more inclined angles.
Okay, how it
Handling
will be
of the
difficult? How it will
rotors,
be difficult?
sir, maybe there are chances that the pellet and the supernatant will get mixed when we try to pull them off or something like that.
Why pellet will mix with the liquid? In fact, it is the pellet is going to be more on the bottom of the tube. The more the angle, the more the pellet will go to the bottom. So maybe can I again go to the whiteboard? Okay, I'll again try to draw the rotor. Okay, this time I'll probably draw only one tube for your understanding. Okay. चंद्रकांत लौटे कौन है? Who is Chandrakant Laute? Chandrakant?
पता नहीं सर.
Okay. किधर है अभी? अरे गायब हो गया. कोणाच्या ओळखीचा आहे चंद्रकांत? एनीबॉडी नोज हिम?
No, sir.
तो ऐसा कैसे लिंक तो किसी ने दिया होगा ना? Somebody has given the link.
Maybe.
Okay. So what I'm going to do now is draw these two situations. Okay. One is where the tube is at an angle of 45 degrees. Okay. And then I will draw another situation, very interesting situation, where the tube is at 90 degree inclination. Okay, and let us see what happens to the sample components. here we have seen, suppose this is your sample. Okay, and here the sample is practically something like this. Okay, just to recollect the earlier situation, in case of the vertical tube rotor, our sample was like this. Okay, and what about the movement of the sample? In this case, suppose these were the sample components. Okay, and now these are the sample components moving from the center of the rotor towards the periphery of the rotor. So this is how the sample components are moving. And then last time, I think with a blue arrow, I showed also the direction of the movement. It is like this. And here the movement is like this. Is it clear to everybody?
Yes, sir.
Okay, so now you can just see the difference. The distance which the components travel is the minimum here, minimum distance. Okay, little more distance here in the fixed angle tubes, and in this situation, okay, the sample components are moving the maximum distance. Okay, maximum distance, and in fact they are going to the bottom of the tube. Is it right? The sample components are moving to the bottom of the tube. Now let me show you again how the sample components would look like. How can I stipple? Okay, sample components are here. Can you see these dots?
Yes, sir.
Okay,
Yes, sir.
I hope this is clear to you. The sample components would probably come here. Okay, and in this case, in fact, all the sample components will go towards the bottom of the tube, exactly at the bottom of the tube. Okay, here it is probably at the bottom, but towards one side. Okay, at the bottom towards one side, and here they will be exactly at the bottom of the tube. Let me show it little like this. Okay, or is it wrong? In
I
fact,
think it is wrong.
it should be here like this. Let me use the eraser. Okay. Okay, sample components are more on this side. Okay, not exactly at the bottom, but somewhere from the bottom to one side. Is it right? Hmm? So is it possible here that we get, because we get the maximum length for the sample to travel, we will get very good separation. Okay, so if you look at the distance between the two boundaries here, or difference between the boundaries here, and the distance between the boundaries here, then you would probably imagine, you will be able to imagine that the separation between the sample components is maximum in this third hypothetical situation, right? But is it possible to have such a rotor? If it is possible, why it is possible? If it is impossible, why it is not possible? Hmm? No answer. Nobody wants to answer.
Don't know, sir.
Yes, Inamul.
Don't know.
I couldn't hear you properly. Is it possible or not?
Sir, I don't think it is possible because
Why?
I have seen rotors inclined at 45 only. I have never seen at
No,
90
see,
degree.
it's not a question of what you have seen or what you have not seen. But can you imagine this situation? That if the tubes are kept parallel to the ground, okay, in a horizontal position, then is it possible to get maximum separation of the components? Theoretically, it is possible, isn't it? But practically, what could be the
Yes, sir.
difficulty?
Sir, maybe it will produce too much of centrifugal force, which will affect the rotors.
Yeah, so
I
that is
think.
always better. No, centrifugal force should be more.
So
More-
maybe it can damage the mechanical system of the rotor.
Why it will damage?
So maybe it can just open off or fall off due to too much force.
What will fall? What will fall?
Sir, the spinning elements or the rotor, sir.
Why rotor will, see, rotor is fixed at the center. See, at this point, okay, I'll just show you the shaft. Okay, the shaft is inside. Sorry, can I adjust the thickness of the line? I do not know, but this is the shaft. This is the central axis of the rotor. Okay, and the shaft is inside. Okay, so this is the shaft on which the rotor is actually placed. Okay, so where is the chance of the rotor falling off? And we are also actually, there is a screw here. Okay, I don't know if I can show this exactly. There is a screwing mechanism, and we can actually screw the rotor in place. Okay, the rotor is actually screwed in place very tightly. Is it okay? See, we are not changing the position of the rotor. We are changing only the position of the holders in which the tubes are kept. Is it right?
Yes, sir.
Okay. In the earlier diagram, I think we have already seen. Let me show you this. Yeah, these are the slots in which the tubes are kept. Okay, so either these slots are vertical inside or they are at an angle. Can you see these holes? Okay, so they are actually cylindrical spaces in which the tubes are kept. Is it right? I have shown this line here. The line indicates the direction of the holders, tube holders, right? So maybe 1, 2, 3, 4, 5, 6, 7, 8. 8 tube holders are there in the rotor. Okay. Okay. So where is my whiteboard? Yeah. So just imagine the situation where the tubes are kept like this in a horizontal position. Okay. And we can easily imagine that the distance traveled by the sample components is the maximum. And therefore, ideally, we should get very good separation here. Not only that, but all the sample components are going to the bottom of the tube. And that also will make us make it very easy for us to separate the supernatant from the pellet, isn't it? Because the pellet is going to stick to the bottom, and therefore the liquid part, the supernatant, can be easily decanted from that tube. Is it right? But the practical problem here is that how are we going to put the liquid in the tube? If the tube is going to be parallel to the ground, okay, then will the liquid be able to, will the tube be able to hold the liquid? Isn't it? That will be a problem, right? And therefore we have a type of a rotor, okay, which is called as the swinging bucket kind of a rotor. Have you used this kind of a rotor anytime? Swinging bucket rotor.
No, sir.
I think you have used it, but you don't remember it. In your chemistry labs, do you remember that on the table? Okay, I'll go to a new screen. Where is it? I don't know. No, I'll have to erase this. In the college, probably you might remember in your BSc, there was a table. Okay, and on this, on the side of the table, there was, I don't know how I can draw this picture. I just try to draw something. There was a stand like this. And there was a T here. And then if you remember, there were circular holders like this. Okay. And inside these holders, there were, I think you have put some tubes here. Oh, I want a straight line. Do you remember this? Okay, so you have put the test tubes here. Or centrifuge tubes. Do you remember? And then there was a handle here. I'll try to show that. And then when you rotate this handle, okay, when you move this handle, then these tubes actually move. Okay, so maybe I'll just show you the movement of this. Suppose you move this handle like this, okay, either in the clockwise or anti-clockwise direction, then these tubes actually would start revolving like this. Okay. Do you remember it or no? So what you do is normally,
No.
yeah, you have
Yes.
prepared some precipitate, some complexes in the chemistry laboratory. Okay, inorganic complexes, if you remember. Precipitates, okay, precipitation reactions. And then after the complex is made, then you take your suspension in the test tubes, in the centrifuge tubes, okay, put it on this hand-driven centrifuge machine, okay, and then you just move this handle with your hands. And when you move the handle, these tubes would start moving like this, okay, they start revolving in circles. Okay, now these holders are not fixed. Actually, these holders, there is a hinge region, okay, there is a hinge region, and therefore as you move the tubes would actually start moving outwards. Okay, so I'll show you the position. Okay, if you move the handle very fast, then the tubes would actually move like this. Okay, then is it okay? So if this was the level of your sample initially, okay, now this sample is actually becoming parallel. The level of the liquid is now parallel to the ground. Okay, and because of the centrifugal force, okay, which is moving, okay, from the center to the periphery, okay, because of this force, the sample doesn't spill out. Okay, sample doesn't come out of the tube, but it is pushed towards the bottom of the tube. Okay, the entire liquid is pushed to the bottom of the tube. And if there are any sample components, okay, if there are particulate matter, if there is particulate matter, then those particles actually would go to the bottom of the tube. Okay, can you imagine this situation?
Yes, sir.
Those who have
Yes,
not
sir.
understood, please ask me again. Okay, Dheeraj.
Yes, sir.
You understood?
Yes, sir.
Okay. Have you used the centrifuge in chemistry lab?
No, sir. Actually, I have seen this at dairy in my village.
In your village? Very good. Okay, that is good. Anybody else who has a problem? Prashant, Sudarshan.
No problem, sir.
Okay. Sheetal is there. Sheetal, your college has not yet started. University department. Sheetal, I'm talking to you. Sheetal, please put on your mic. Ah. Have your lecture started? Sheetal. Sheetal, are you able to hear me? Maybe I'll talk to you later. Okay, Prashant, do you have any difficulty?
No, sir, not difficult.
Okay, Sudarshan, Aishwarya.
No, sir.
Okay, Pooja. Pooja, have you understood?